2.4 is reasoning in algebra. Okay. And our goal today is to connect reasoning in algebra with geometry. So here we're going to start working with some algebra stuff, and we're going to link it with the things we're doing in geometry. So we're going to use rules that we know in geometry to set it up, and then in the steps that we solve, we're using our algebraic steps in order to solve it, and we're going to name those algebraic steps, okay? That's what we call reasoning. So you're giving a reason as to why you perform a specific step. So the addition property of equality says that if A equals B, then A plus C equals B plus C. So if you add a number on both sides of your equation, we call that the addition property of equality. So when you are solving, okay, if I'm solving something and I have to add a number to both sides, that step that I'm performing is called the addition property of equality, okay? So we're going to have to start, when we're showing our work and solving an equation, next to it, we're going to write addition property of equality, okay? The next one's going to be the subtraction property of equality. So if A equals B, so if you have an equation and you subtract a number on each side, you subtract C on both sides, that's called the subtraction property of equality. If you have an equation and you multiply by a number on both sides, that's called the multiplication property of equality. The division property of equality says that if you have an equation then you can divide by a number on both sides. So this would be A over C equals B over C, because we're going to divide by C on both sides. Okay. The reflexive property just says that anything is equal to itself. Okay, something is equal to itself. The symmetric property says that if A equals B, then B has to equal A. So you can reverse it. This means it's a conditional statement. If this, then that. Okay, we'll just stop writing the if then part of it. Okay. Transitive property is similar to the law of syllogism that we were working with. Okay. This is if you have, if A equals B and B equals C. So you have two things. A has to equal B and B has to equal C. This also means that A equals C. Okay, so you can start with the first thing and get to the last thing. So it's kind of like that law of syllogism. If this, then this. If this, then that. If this, then that. Okay, but this is just what we use when we're dealing with equations instead of a list of conditional statements. The substitution property of equality says that if you know that A equals B, then A and B are interchangeable. So you could replace A in an equation, you could replace B in an equation with A. Okay, so you can do that in an equation if you know that A equals B. You can replace them with each other. They're interchangeable. And the distributive property says that if you have something times a sum, okay, you have something times the sum of another two numbers, then this would be the same thing as A times B plus A times C. Does that look familiar? Okay, good. Okay, that's just the distributive property of equality. Transitive, symmetric, and reflexive, transitive, symmetric, and reflexive property can also be of congruence. So if you have, instead, remember when the difference between congruent and equals? Can anyone tell me what the difference between congruent and equals is? Anyone remember? Or want to take a guess? The difference is what it is you're talking about. So what are equal? Numbers. What else what'd you say? Numbers. Okay, so numbers, yep, numbers are equal. Okay, which also represents distance. Distance is a representation of, or numbers are a representation of distance, right? That's how we represent distance as numbers. So things that are equal are numbers, like distance. Okay, what's congruent then? What are things that can be congruent?
Letters.
Not letters. Letters don't really mean anything in math. Well, they all have different meanings, but you have to be more specific on what kind of letters could be congruent. What are those letters actually representing? Go ahead.
Degrees.
Nope, degrees would be the measure of angles, and degrees are represented in numbers, so those would be marked equal. Okay? So that's the measure of angles are marked equal. What would be congruent, though? What is it? Segments can be congruent. Segments could be congruent. What else could be congruent? So figures. Figures of geometry are what we can say are congruent. So segments are congruent. Planes would just mean that they were the same plane. You wouldn't have congruent planes because planes go on forever. Same with lines. Lines go on forever, so I guess you could say kind of that all lines are congruent. Because in order for figures to be congruent, they have to be able to basically lay on top of each other and be the exact same size and have the exact same angle measures. Okay? So angles can be congruent. Segments can be congruent. Those are the two big ones that we've already been talking about this year. Okay, our angles and segments. So figures, geometric figures can be congruent. All right? So, in this example, it's going to give us that the measure of angle AOC is 139 degrees. Okay? And then it has those two other angles labeled. So we're going to go ahead and we're going to figure out how do we set this up and give reasoning for each of our steps. Okay. So I know the measure of angle AOC is 139 degrees. That's the whole angle, AOC. Okay, the measure of angle AOC is 139 degrees. This one here is the measure of angle AOB. So the measure of angle AOB is labeled 2x plus 10. And the measure of angle BOC is labeled x. Okay. So those are all givens. Those would be given to you. Now, the AOB and the BOC we were able to come up with because it was given in the diagram. But the measure of angle AOC, that would have also been given to you. Okay. So if I want to solve for x, what is my setup going to be here? How could I come up with an equation? Go ahead. Yes, that is the setup. So your 2x plus 10 plus the x equals 139. Okay, because part plus part has to equal the whole thing. Okay, that's your algebraic setup. Okay, you could have even done one step before that and said, labeled it the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. AOB plus BOC is equal to AOC. What rule allows us to set this up? It's something that has addition in it, but there's a whole name. It's not one of these rules. It's a previous rule that you guys learned in Unit 1. What is it? That was the idea of it, part plus part equals whole, but what was part? That was our setup, but what was that setup to? What type of problem was it? Remember I had made you guys name the types of problems? This is why. We have to know the type of problem this is because our setup was part plus part equals whole. What type of problem is this? What kind of addition? What are we adding here? What are they? Not things. Things is not a very good word. What are we adding? Go ahead. Angle addition postulate. That's what it was called, the angle addition postulate. Okay, so that's our rule here, is the angle addition postulate. That's what allows us to do that setup, because the angle addition postulate says adding two angles together, two adjacent angles together, will equal the whole angle. So we can set that up because it's the angle addition postulate. Okay, that was the first one. How did I then come up with, instead of the measure of AOB, I'm going to replace it with 2x plus 10. Instead of the measure of angle BOC, I'm going to replace it with x. Instead of the measure of angle AOC, I'm going to replace it with 139. What allows me to replace those with those expressions and numbers? Substitution, yes. So the second step is the substitution property of equality. Okay, so I'm allowed to set up my first one by the angle addition postulate. My second one is the substitution property of equality. What am I going to do next? I need to solve for x, so what do I do next? Go ahead. Combine like terms. Oh wait, you just gave me the reasoning. You said combine like terms. Combine like terms. What do I get when I combine like terms here? (3x plus 10 equals 139 still. You can say combine like terms. You could also say simplify here. I don't care which one you use. I usually write simplify because it's shorter than writing combine like terms. Either one would get you points on a test. Simplify or combine like terms. Does that make sense? Okay. And then what? Go ahead. Subtract 10 from both sides. Wait a minute. You just told me the rule. What's the rule? What's the next reasoning? What are you going to do? Subtract 10 from both sides. So what's our reasoning have to be here? If you're subtracting, it's right up in here somewhere. Which rule does it follow? The subtraction property of equality. It's really important that you don't abbreviate it as sub. A lot of people try to do that every year. If you abbreviate something sub, I don't know if it's supposed to be subtraction or substitution. So it's really important that you actually write all these words out. Okay? You can abbreviate property of equality, POE, or property of congruence, POC, but your word before that needs to be written out completely. And right on your test, it'll say no abbreviations except POE are allowed. Does that make sense? Okay, so I subtract 10 from both sides, and I get 3x equals 129. I don't necessarily need to show that work in between. If you do need to show the work, showing of the work doesn't require a label. That is the subtraction property of equality. Does that make sense? So I don't necessarily have to put that in there. Okay, what should I do now? I'm going to divide. So what's my reasoning going to be? Division, property of equality. And I'm going to get x is what then? When I divide by 3 on both sides, I get x is, anyone have a calculator? 43? And there I go. I finished my problem. I could go back and then plug it in and make sure that my answer and my work here is right. I can plug 43 in, 2 times 43 plus 10 here. You guys can't even see what I'm pointing at. There we go. Okay, so I'll plug in 43. 2 times 43 plus 10. It's 96. So if I label this as 96 degrees, and then x was 43, so this would be labeled 43 degrees. We can double check that 96 and 43 add up to 139, which they do. And so now I'm confident that I did that right. Okay. Does that make sense? Can we handle this? So if you flip the page, you guys are going to have some time to work. Okay. The work is already done for you. Notice that you don't even have to do the setup. You don't have to do the solving here. It's already done. You just have to relate it to a step. Okay? You're just going to relate it to a step. So I will give you some time to work on that, and then we'll do our other notes.